All right, the method of elimination. So we've learned about how to graph a system, which works really easily if you have, one, small values that you're dealing with, and two, if it's going to be whole numbers. We learned about substitution, which was our algebraic way of being able to solve, and those worked best when you had it where either both equations were set up in y equals format or x equals format, or at least one equation was written in y equals or x equals format. But here, elimination is best used when neither one of your equations are solved in y equals format or x equals format. They are both best, or if they're both set up in standard form being that ax plus by equals c, and we'll write that above here. So remember, standard form was x, where a represented a number and x was a variable, plus by, where b represented a number and y stays a variable, and it's equal to c. So if you have both of them set up in that form, ax plus by is equal to c, then elimination is going to be your best bet, your easiest way of being able to solve. So yesterday, and the day before, when you guys were doing stations, you had some problems in which both of them were written in this format, but I still had you using substitution, and that was a longer process, and there were mistakes that were made because rewriting and then doing substitution, it takes a lot longer, and you're more likely to mess up somewhere because you might have dropped a negative sign, or you forgot to divide by a negative sign. You didn't substitute correctly, you didn't distribute fully. There could be a lot of room for error. Elimination kind of shortens the process a bit and makes it so that there's not much error involved. So in order for you to be able to use elimination, the first thing that you would have to do is you're going to set your system up so that both of your terms are set in the same format. So if you have ax plus by is equal to c, then your next equation has to be ax plus by is equal to c, where your x's are aligned one above the other, your y's are aligned one above the other, and your c's, you only have a single number value that it's set equal to. You want that alignment to happen. Then you need to either create or identify a zero pair. Sometimes maybe your x values, your a values might be zero pairs. Maybe one of them's a positive 2 and the other's a negative 2. That's a zero pair. So if you can identify your A's as zero pairs or your B's as zero pairs, you're good to go. If you don't have a zero pair set, you'd have to create one by multiplying one of the equations or both of the equations by a common factor. So meaning that you're trying to create a zero pair. So if you have a 3x and a negative 4y, then your common multiple, or your least common multiple, would be 12. So you would multiply your first value by a set of 4s, and you would multiply your second value by a set of 3s, so that you can create a zero pair of 12 and negative 12. Okay, and we're going to do a lot of examples of those. Then you can eliminate the zero pair by combining those values together. Addition will allow you to eliminate opposite values. So a positive 12 and a negative 12 would eliminate out, and your other variable would be left isolated. Okay, so you'd only have one variable remaining. Once you have one variable remaining, you'd solve for what that variable equals, and then you'd do the same process that we did with substitution. You'd substitute it back into one of the original equations, not the multiplied equations, but one of the originals, and then figure out what the other eliminated variable is equal to. And like always, you check with the unused equation, okay? Always do that check method. The check method will tell you whether you got it right or wrong, all right? So let's take a look at a couple of examples here. And I'm actually going to go ahead and highlight each of these steps in a different color. So that way when I'm working through the problems, I'll work through step 1 always in blue. So I'm going to highlight step 1 in blue, so that way when I'm working through step 1, it's in blue, and you'll see what I'm doing. You'll know that it can mirror back to I'm aligning them. I'm making sure that they're set up in an aligned value. Step 2, I'm always going to use my pink to work through. So if I'm identifying or if I'm having to create common multiples or least common multiples and multiplying by a common factor, I'm going to do that in pink. In green is when I'm going to go ahead and eliminate whatever the zero pair was. So you'll see that process happen in the green. My purple, actually no, not my purple, we'll do the orange. My orange is going to be me substituting and solving. And then my purple is going to be the process of me checking. Just like in substitution, I always used purple to check. I'm going to do the same thing for here, so that way it's just all the same. Okay, so taking a look at the very first set of equations, linear equations, I've got x minus 2y is equal to negative 19, and I've got 5x plus 2y is equal to 1. So the first thing I need to do is I'm going to rewrite these so that they are aligned one above the other. And I want to make sure my x's are in the same position, my y's are in the same position. So that's my very first step. Step 1, we're going to align. Step 1 is to make sure that we align. You got a copy. The fact that some of you are sitting there without even a pencil out, how are you going to take notes? Okay, so we are going to rewrite this. We are going to write x minus 2y is equal to negative 19. And we're going to put 5x plus 2y is equal to a positive 1. Okay, step 2, which is what I'm doing in the pink, is to either identify or create a zero pair. In this case, I can identify because I see that there is a zero pair already. Remember, zero pairs are same base numbers but opposite signs. Which variable has a same base number but opposite signs? The y's, right? So right here, and I'm going to identify their positive and their negative. I'm going to put a box around it. That is going to be my zero pair. My negative 2y and my positive 2y. Those are going to create my zero pairs. So, got that. Step 3, the process for step 3 is to go ahead and eliminate. Eliminate and solve. We're going to eliminate and solve. Okay? So by eliminate, since it's already a zero pair, I'm going to go ahead and just cross them off. They are eliminated. I'm going to draw a line below here, and I'm going to go ahead and combine these values together. What is x and 5x combined together going to create? 6x, because there's a positive 1 in front of that x. So that means I'm going to have 6x is equal to, what is negative 19 and a positive 1 going to equal? Negative 18. Okay, and now in order for me to solve this, I now have to go ahead and divide both sides by a positive 6, and I'm going to get that x is equal to negative 3. So I have my value for x. From here, I go on to step 4. Step 4 is to substitute. So I just pick one of the original equations to substitute this x value into. It does not matter which one I choose. I'm just going to go ahead and go with the first one. So I have x minus the 2y is equal to negative 19. I'm going to replace that x with what I just solved for, which was negative 3. So I have negative 3 minus 2y is equal to negative 19. And now I go about the process of solving. My first step is to go ahead and add 3 to both sides. That gives me negative 2y is now equal to a negative 16, sorry, negative 16. And then I'm going to divide both sides by a negative 2, and I'm going to get that y is equal to a positive 8. Okay, and then my last step, the last thing that I want to go ahead and do is check. Now remember, when you check, you use the equation that was not used for substitution. So the equation that we did not use for substitution was the 5x plus 2y is equal to 1. Please copy this down. Come on. 5x plus the 2y was equal to 1. We're going to go ahead and substitute our x and y values in. So we're replacing this x with a negative 3. We're going to replace this y with a positive 8. So we have 5 times negative 3 plus 2 times positive 8, and we're going to check to make sure that it equals 1. 5 times negative 3 is a negative 15. 2 times 8 is a positive 16, and when I add those together, I do get a value of a positive 1. So there's my solution. My final answer, you always write your final answer in coordinate grid form or ordered pair form. Negative 3 for your x and a positive 8 for your y. There's your answer. Okay, again, let me go through that process one more time. The first thing that we had to do was align the equations up so that your x's were on top of each other, your y's were on top of each other. You then identified if you had a zero pair, or what we'll show you later is how to create a zero pair if there's not one already there. And then you eliminate the zero pair and solve for the variable that's left over. Once you've got a value for your variable, you substitute it back into one of the original equations. Typically, I go with the first one. Substitute it in, solve for the y value, or whatever the remaining variable is, and then take both answers that you got and substitute it into the second equation that you did not use. Everybody clear? Okay, so then what I want you guys to do is you're going to try problem number 2 on your own. Okay, let's go ahead and go over this one. Like I said before, your very first step, step 1, we are going to go ahead and align the equations. That means that I'm going to rewrite these. If I wanted to start with the y plus 3x is equal to negative 2, y plus 3x is equal to negative 2, then the way that I would write this second equation means I'd have to put this positive 2y in front and this negative 3x in the back. So I'd put minus 3x, 2y minus 3x. Now I could have done negative 3x plus 2y is equal to 14 and then just rewrite this as positive 3x plus y. Either one of those would be perfectly fine. It'll come out the same. It does not matter the order that you write the first one or which one you choose to write for your first one, as long as you mirror that order for your second equation. Okay, so I've rewritten. Now step 2. Step 2, I need to either create or identify. So the first thing I'm going to check, do I have a zero pair up here? Yes. Which variable is the zero pair? The 3x and the negative 3x. So I do have, so identify my zero pair, because I do have one. It happens to be right here. The positive 3x and the negative 3x are my zero pairs. My step 3 is to go ahead, eliminate, and solve. Step 3 is to eliminate the zero pair. So to eliminate, all I got to do is just cross them off. And then I'm going to solve. I'm going to solve for the y. So y plus 2y is going to equal 3y. And then negative 2 plus the 14 is going to come out to a positive 12. And then I'm going to go ahead and just divide both sides by 3. And I'm going to get y is equal to a positive 4. So I've solved for y. Now I'm going to move on to step 4. I'm going to go ahead and wrap it on over here. Step 4 is to substitute my y is equal to 4. Does it matter which equation I choose? No, I'm just going to go with the first one. Like I said, I always tend to just go with the first. So we have y plus 3x is equal to negative 2. I'm going to replace the value of y with a positive 4. So I now have 4 plus 3x is equal to negative 2. I'm then going to subtract 4 from both sides. That leaves me with a positive 3x is equal to a negative 6. And then I would divide both sides by 3 and get x is equal to negative 2. So I now have my value of negative 2 for x. My last step always is to check. Okay, when I check, I must use my second equation, the equation that I did not use, to substitute it into and check. So negative 3x plus 2y is equal to 14. That now becomes negative 3 times negative 2, because that's my x value, plus 2 times a positive 4, because that was my y value. So I'm replacing that with the y. And it's supposed to be set equal to 14. Okay, and I'll zoom in so you guys can see that a little bit easier. Negative 3 times negative 2 comes out to a positive 6. 2 times 4 comes out to a positive 8. And when I add those together, I do get 14. So then I have a solution. My solution is my x value first. X always must be written first. Negative 2, positive 4. There's my solution. Okay, so those are what to do when you have a zero pair already created. Sometimes, though, you won't have a zero pair. So it won't be step 2 to be identifying. Sometimes step 2 might be creating. So let me show you how to create. Let's take a look at problem number 3. Oh, no, problem number 3 already has a zero pair. Never mind. Go ahead and work this one out. I think it's problem number 4 that does not have a zero pair. Yeah, problem number 4 doesn't have it. My bad. Go ahead and do problem number 3 real quick. Okay, let's go ahead and go over problem number 3. For problem number 3, the very first thing that you're going to do, so I'm going to zoom in so that we can see it step by step. First thing that you're going to do is align your equations. We're going to have it 3x plus 4y is equal to 18. Underneath it, it's going to be 2x minus the 4y is equal to negative 8. We do have a zero pair. The y's are a zero pair. You've got a positive 4 and a negative 4. So you can eliminate those and then solve. When you combine 3x and 2x together, you get 5x. Positive 18 and a negative 8 combined together will give you a positive 10. Then you solve for x by dividing both sides by 5. You get x is equal to 2. You then take that value and you go to step 4. Step 4 is to substitute it into one of the equations. I used 3x plus 4y is equal to 18. That becomes 3 times 2 plus 4y is equal to 18. 3 times 2 is equal to 6. You would then subtract the 6 from both sides for solving. That would leave you with a positive 4y is now equal to 12. Then you would divide both sides by 4 and you get the y is equal to 3. You then take your value of x equaling 2 and y equaling 3 and you substitute it into the other equation. So we're going to have 2 times 2 instead of 2 times x, minus 4 times 3 instead of minus 4 times y, and it's equal to negative 8. 2 times 2 is 4, and then negative 4 times 3 is negative 12. 4 minus 12 comes out to negative 8, so it does work. It is a true solution, so I can check mark that off, and then write it in my ordered pair. My ordered pair is positive 2, positive 3. Okay, so those are the situations in which we have an identifiable zero pair. Problems 4 and 5, we don't have an identifiable zero pair, so we have to create a zero pair in those situations. So let's go ahead and look at our last page. So for problem 4, again, I'm going to go through the process of aligning first. That's always going to be my very first step. Step 1. Step 1 is always going to be to align. It does not matter the way that I align it as long as I am consistent. So I'm going to go ahead and start with negative 7x plus 12y is equal to 22. And then negative 5x plus 8y is equal to 14. So I don't have a zero pair here. That means I have to create a zero pair. And that means that I get to decide which variable I want to eliminate, whether I want to eliminate the x's or if I want to eliminate the y's. It doesn't matter which one. For me, I'm going to go ahead and choose to eliminate the y's. I'm going to solve for x first. So that means I'm going to look at the 12 and the 8, and I need to multiply them by different values. Obviously, if I multiply them both by 2, is that going to create a 0 pair? No. I'm going to multiply them both by different values to create a common multiple, the least common multiple. So it's kind of like when you used to create equivalent fractions, you are doing the same thing. So 12 and 8, what is the smallest common multiple that they have? Those are factors. Those are factors. What's the common multiple? 24. 24. If I multiply 12 by 2, that creates 24. If I multiply 8 by 3, that creates 24. Now, notice that they both happen to be positive right now. 0 pairs are opposites. So one of them has to change to a negative. How do I change one of them to a negative? Multiply it by a negative. So one of these equations is going to get multiplied by a positive value, and one of them is going to get multiplied by a negative value. It doesn't matter which one you decide to multiply by positive or negative, as long as you do it consistently throughout. I'm going to go ahead and take the first equation. I know I need to multiply by a factor of 2. I'm just going to go ahead and make that one the negative. I'm going to multiply it by a negative 2. And then the other one, I'm going to multiply it by a factor of 3. So here's what I mean that you have to multiply everything by a factor of 2. Notice I didn't just say, okay, I'm going to multiply the y's by a factor of 2. If you multiply the y by a factor of 2, you've got to multiply all of it, because all of it has to change in order for it to stay an equivalent equation. So that means I'm going to multiply here by a factor of negative 2. I'm going to multiply the 12y by negative 2. I'm going to multiply the 22 by a negative 2. And then the same thing for the bottom equation. I'm going to multiply that negative 5x by 3. I'm going to multiply the 8y by 3. I'm going to multiply the 14 by 3. So doing so is going to create new equations. So that's what I did for step 2. I'm going to create, this time, a 0 pair. I have to create a 0 pair. So when I do that, what is negative 2 times negative 7x going to become? 14x. What is 12y times negative 2? Negative 24y. And what is 22 times negative 2? Negative 44. Be mindful of those negative signs. Okay, let's do the second equation. I'm multiplying everything by 3, so it's negative 5x times 3. Negative 15x. What is positive 8y times 3? Positive 24y. Okay, so I'm putting my plus 24y. What is 14 times 3? 42. Okay, so now I've created these 0 pairs. I can go ahead and identify the 0 pair. The 0 pair is the y's. I have a negative 24y and a positive 24y. Step 3 is the same as always. We're going to eliminate and solve. Step 3 is to eliminate and solve. So we're going to eliminate the 24y's and the negative 24y's. And then I'm going to combine my terms. What's 14x and a negative 15x? Negative x. I'm going to go ahead and put negative 1x just so that I know that that's a coefficient of not a positive 1, which means I'm going to have to divide eventually. And then negative 4 and positive 42. Negative 2. Okay, and so then my last step is to divide. And here's where a lot of you went wrong yesterday. When you had a negative coefficient and you were supposed to divide, a lot of you divided by the positive. In order to get x isolated, you have to divide by the entire coefficient, including the negative. Okay, so you got to divide by negative 1. and that becomes x equaling a positive 2. Okay, so we solved for x. We're now going to take that value of x and we're going to follow it up to step 4. And step 4 is to substitute. Step 4, we're going to substitute. Okay, now, am I going to choose one of these equations right here that I wrote? No, because what if I made a mistake here? If I made a mistake here in my multiplication, and then I substitute it into my mistake, it's going to show up correctly for the mistake, not for the originals. You always substitute back into original equations, never what you rewrote. Is that understood? Because if you made a mistake in the rewrite process, you won't be able to find that you made an error when you check it. Okay? So we're going to substitute it back into one of the originals. I'm going to go ahead and substitute it into the negative 7x plus 12y is equal to 22. So I'm replacing my x. My x is going to be replaced with a value of 2. So it becomes negative 7 times 2 plus 12y is equal to 22. Negative 7 times 2 is negative 14. So we get negative 14 plus 12y is equal to 22. I then add 14 to both sides. That gives me 12y is now equal to 36. My last step is to divide both sides by 12. Okay, and I know I'm going real quickly through the solving portion, the substitute and solve, because at this point you guys should know how to solve these two-step equations easily. Okay, and that becomes y is equal to 3. Last thing to do is just to check. Okay, so we're going to substitute everything into negative 5x plus the 8y is equal to 14. So instead of negative 5 times x, it's negative 5 times 2. Instead of 8 times y, it's 8 times 3. And we want the whole thing to still equal 14. Negative 5 times 2 is negative 10. God bless you. 8 times 3 is positive 24. And when we do negative 10 plus 24, we do get 14. Okay, so there's our solution. Positive 2, positive 3. So I'm going to do the last one with you guys again, because I want to make sure that you do still understand how to create the zero pairs. If you feel confident with it, you can just keep going past me. You don't have to wait for me to go step by step. If you need to have a little bit more practice with me, then make sure you're just paying attention and following along. Okay, so you can either go through it real quick yourself and then check to make sure you have the correct answer at the end when I'm done going over it. All right, let's take a look here. Step 1, what was step 1 to do? Always, always, always. What is our first step? Align. First step is always going to be align. Okay, so I'm going to write 8x minus 14y is equal to 10. And then 9x minus 7y is equal to negative 15. Okay, like I said before, when I'm having to create a zero pair, it doesn't matter which one I choose. However, in this situation, there's a glaringly obvious one that I should go with. Which variable do you think I obviously should go with? The x or the y? The y. Because your common multiple is 14. If you've got 14 and 7, can't we change 7 into a 14? Yes or no? What do we have to multiply 7 by to get to 14? 2. So do I have to even change anything about this 8x minus 14y is equal to 10? No. So sometimes you want to go with a variable in which you only have to change one of the equations. So that way it makes it less likely to make a mistake. Now, because of the fact that they both happen to be negative, it means I'm not going to just multiply by a 2. I want to change this to an opposite. I'm going to multiply by a negative 2 so that I can change that minus to a plus. So we're going to multiply everything here by negative 2. I'm going to multiply this one by negative 2. I'm going to multiply this value by negative 2. I don't have to change the 8x minus 14y equals 10 at all. So my step 2 was to create the 0 pair, which is what I'm doing right here. 8x minus 14y equals 10 is going to stay exactly as it is. My second equation now becomes negative 18x plus 14y is equal to a positive 30. And there's my 0 pairs, negative 14y and a positive 14y. Okay, step 3, we eliminate and then solve. Step 3 is to eliminate and solve. We're going to eliminate the negative 14y and the positive 14y and then combine these together. 8x and negative 18x becomes a negative 10x. And then 10 and 30 comes out to 40. Our last step is to divide both sides by negative 10, and we get x is equal to negative 4. Okay, from here we then take this value and we're going to go to step 4, which is to substitute. Remember, like I said before, you must substitute it back into an original equation, not one that you rewrote. So we're going to go ahead and substitute it into 8x minus 14y is equal to 10. That means it's going to become 8 times negative 4 minus 14y is equal to 10. 8 times negative 4 is negative 32. Minus 14y equaling 10. We're going to add 32 to both sides. That negative 14y, that minus 14y must come down like a negative. So you have negative 14y is equal to positive 42. You will divide both sides by negative 14 and get that y is going to be equal to a negative 3. So we have solution of negative 4 and negative 3. We want to double check to make sure that it is correct. So we substitute it back into the second equation that we did not use for our check method. 9 times x minus 7 times y is equal to negative 15. That becomes 9 times negative 4 because we're substituting negative 4 in for the x. Minus 7 times negative 3. Because we're substituting negative 3 in for the y. And the whole thing's equal to negative 15. Okay, 9 times negative 4 is a negative 36. Negative 7 times negative 3 is a positive 21. And when I combine those values together, I do get negative 15. So that means I have worked it out correctly. So my final solution is negative 4, negative 3. Okay, your assignment for tonight, you have IXL. You have one IXL that's going to be practicing just substitution, which is what we did for the past couple of days. You have one IXL that's going to practice elimination, so it's purely an elimination process. And then you have a third IXL in which it's a combination of the two methods, meaning you're going to have to choose which method to use based off of the setup. Is it better to use elimination or is it better to use substitution? And you'll go through those. Any questions?